What impeccable timing. A rare and astonishing moment has arrived. Three objects called the Three-Eye Atlas pass by Mars. On October 4, 2025, this object is moving away from its closest point to Mars, yet remains close enough for it to matter. Yesterday, on October 3rd, he reached his closest distance to Mars. From Earth, it is almost impossible to observe it, as the brightness of the sun obscures this area, and the object is effectively hidden behind it. This makes the spacecraft orbiting Mars our only real vantage point for observing the Three-Eyed Atlas at the moment. Ironically, many NASA websites and channels fell silent due to a government shutdown just when we needed real-time updates. The halt of key public access during an interstellar flyby seems too convenient, especially as researchers worldwide strive to monitor what might be the most unusual object ever seen in our solar system. Intense speculation is underway. Some suggest it could be an active moving comet, unlike anything we've seen before. Others propose more exotic theories: a probe from beyond the stars, part of technology, or an alien craft. Regardless of whether these theories are plausible, the timing of this blackout raises questions. Fortunately, we may have a lead. On October 2nd, the rover Perseverance captured an image with a streak visible in a long exposure. This streak does not match the usual motion of the Martian sky background. Instead of being vertical or aligned with the star trails caused by Mars's rotation, this path is tilted and constant across all images. It is a real object. It is not a glitch. It moves quickly. It can be assumed that we saw the Three-Eyed Atlas. The credit for noticing this stripe belongs to Drew, whose tweet prompted further investigation. The size of the object remains a mystery, but estimates of its minimum dimensions are around 5 kilometers wide, possibly even more. It does not have a huge classical comet tail. Instead, it appears to be enveloped in a vast diffuse coma of ionized gas and dust. Its speed is extraordinary, at nearly 60 kilometers per second, accelerating to a peak of about 68 kilometers per second as it approaches perihelion at the end of October. Around September 25th, a coronal mass ejection burst towards the Three-Eyed Atlas, which could ionize or activate its surroundings. However, the subsequent images taken on September 27th and October 2nd do not show catastrophic restructuring, nor sudden loss of the tail or fragmentation, only hints of a gradual expansion of its shell. Therefore, the illumination from NASA was so important for everyone. Fortunately, we are not defenseless. Mars Express and ExoMars Trace Gas Orbiter were also ready to observe the Three-Eyed Atlas during its close approach, capturing images, spectral characteristics of gas, and tail dynamics. The upcoming JUICE mission will intercept an object as it continues its journey towards perihelion. However, communication with Earth will delay most of the data delivery. Together, this data could create a clearer picture of the Three-Eyes Comet. All eyes are now focused on the European Space Agency, our best hope for new images of the Three-Eyes Comet. How large is the Three-Eyes Comet? Determining the true size of the comet can be difficult. The challenge lies in separating the nucleus from the blurred coma around it. When a comet approaches the sun, its frozen ice turns directly into gas, releasing streams of dust into space, forming its characteristic tail or coma. This can make the comet significantly larger and brighter than the solid body itself. A team from Harvard, led by Richard Clutie, Avi Loeb, and Peter Varesh analyzed observations of the comet Three-Eyes collected from May 15th to September 23rd from 227 different observatories worldwide through the Minor Planet Center. They compared the actual trajectory with the path we would expect if only gravity were acting. They found a small but noticeable effect, less than 15 meters per day squared. However, comets with active gas jets usually receive a small push from the outgoing gas streams. In the case of the Three-Eyes Comet, the measured non-gravitational acceleration is surprisingly low compared to the observed gas emission. This suggests that the core is heavy enough to resist significant impact from these jets. Based on this, researchers estimate the core mass of the comet to be over 33 billion tons, with a diameter of about 5 kilometers, not including the surrounding coma. This is about 3 to 5 orders of magnitude greater than previous interstellar visitors. Loeb claims that, given what we know about the available population and the abundances of heavy elements in interstellar space, we should have seen many more modest-sized interstellar objects before encountering something so massive. Nevertheless, this did not happen, and it highlights the Three-Eyes Comet as a significant exception. Loeb even considers a speculative alternative that the object may have a technological origin, mentioning its unexpectedly large mass, the alignment of its trajectory, and some supposed detections of nickel without iron as provocative hints. However, NASA scientists urge caution. The prevailing opinion remains that it is most likely a natural object. As for the images, we also saw that the coma is active, indicating that there is a coma around the nucleus, suggesting that this object is indeed a comet. Meanwhile, some scientists wonder not what the three eyes are, but what role it may play. Astrophysicist Susan Falsner's idea is simple yet astonishing. The three eyes could be the seed for creating a planet. But how can a wandering stone from another star system cause the birth of an entire planet? Let's embark on a journey. We enter a young solar system, where a new star is at the center of a large dusty ring. Here, tiny grains of stone swirl like smoke, merging into pebbles. Over time, they turn into boulders, and then into planetoids, raw material for forming planets. Given enough time, these objects grow so large that they can gather even more material. At first glance, this seems simple, but as we will see, there is a serious problem in this description. Disks exist for only a few million years before the gas dissipates. This time frame seems too short to explain how massive planets like Jupiter and Saturn could have formed. Now imagine another scenario. An interstellar object enters this disk, a body already large enough to serve as a solid core, suddenly allowing the disk to attract surrounding gas and material. Thus, an alien traveler could accelerate the process of a new planet's birth. Falsner's modeling confirms this idea. She found that massive stars capture interstellar objects better than smaller ones. Indeed, gas giants are more commonly found around larger stars. The coincidence between theory and observations is striking. If this is the case, then interstellar objects like Oumuamua, Borisov, and Atlas are not just random wanderers. They can be sparks that ignite planetary systems. Some of them could have formed the basis for gas giants in distant systems. Others might have even played a role in the early history of our solar system. This is a bold idea, and it remains unproven. Like lobes, studying interstellar objects is notoriously difficult. They appear suddenly, move quickly, and disappear into the darkness. But this time we are ahead of the events as we manage to detect it in advance. Our technology may finally allow us to reveal its true nature, rather than just speculate after its disappearance.